So it's late in the evening for you there, huh? Or
Yes, yes. I just finished some some customers meetings,
ah,
and this is the fun part actually.
oh, good.
Something
Okay,
that I like to do it. So yeah,
glad to hear that.
yeah. Hello, Jackie. Can you
Hello.
hear us? Hi.
Can you hear me?
Yes, we can hear you.
Great.
Okay. Let me see how I can share my screen here. I will share entire screen. So now you should be able to see my screen, correct?
Yeah. Yep.
Yes.
Yep.
Hi, Phil.
Hello.
Hello. Hi. Let's see if others will join. Let's wait 1 or 2 minutes and then we can jump in. By the way, have you worked until now with Databricks?
Yeah, I'm doing a little bit at my work currently.
Mm-hmm. Okay. And it's in which direction? Machine learning or data engineering?
So far, just data engineering, but
Data engineering, yeah.
I'm hoping to get into the machine learning as soon as
Into the
possible.
fun part.
Yeah.
Yeah, I see.
I've never used it. It's my first
Okay.
time.
No problem. It will be an interactive session. We will cover a lot of things, and I'll also explain you what Databricks is as a platform, what kind of problems it solves. So hopefully, at the end of the session, you'll also have something to try, so you can build your own portfolio if you want, or use those notebooks to show to your colleagues, or to improve them, maybe, or maybe to improve them also, right? All right, so I believe we can start. If the others will join, they can catch up. So my name is George. First, I'm living in Germany, and I'm working with Databricks since the last couple of 6-7 years. I've implemented projects at customers for more than 13 customers in the Europe region. And I also started as a data engineer a couple of years back, and then moved towards consulting. And now I'm Databricks partner manager at a company called Adastra. And my free time, I'm also writing some Medium articles on this page, and if mostly about Databricks, machine learning, or newly Gen AI. Or you can also find me on my LinkedIn page. So if you want to stay in touch, this is also one of the options. Or on Super Data Science, of course. If you have questions about Databricks, you can write me a message also there. I'm available. So what are we going to cover in this course? We're going to cover what Databricks is, and we'll train a machine learning churn model. We'll train a churn model to see how this works in Databricks. We'll not go into the intuition of the model. For example, what XGBoost is and how this works in the background. I believe you will find a lot of information about that on the Super Data Science platform. The courses from Kirill and Adeline, they are amazing. I also done it, so I'm really happy with the content there. So we are going to start with Databricks free edition, so that you can also check by yourself and try it after this session. I prepared notebooks for you. You can download it and try it by yourself. We're going to its free edition, but I'm also going to show you the full edition, one of the feature there, which is called Auto ML. I'm going to show you how this works, because I believe this is also a good start if you want to check Databricks. So let's dive in. If you want to later download the course, I'll post this GitHub link in the chat. So I'll put it here so that you can download it. So basically this contains a churn dataset and churn prediction DBC file. I'll show you right away how you can import this DBC file. It contains for notebooks. And if you want to start with Databricks, the best option is to go to Google and search for Databricks free edition. Now, important part here, don't go for this one, sign up for free edition. Search for this one, free edition, replacing Databricks Community Edition. So this is the one that we want for this course. And it covers all of the features that we wanted. Once you go in, then you have to go here to sign up for free edition. By the way, should I zoom in, or it's okay for you? Because I have a wide screen. Is it better now?
Yeah, that's good.
Yeah. Okay. Great. So just let me know when you see something. Then I can adapt. And then you go here, sign up for free edition. Just a normal form. You just have to enter your email, and then you'll get some verification code that you can enter. Something like this. This is already expired for my account. So once you have this account here for free edition, then you are ready to go, and you'll find one of these Databricks workspace, which looks more or less like this. You'll get a link, and this is my Databricks so-called workspace. And in this workspace, we are going to work in this session. Before that, what we cover here in this menu, you can see here workspace, catalog. What are these menu points, right? So Databricks is a platform where the so-called unified platform where more than one persona can work together. For example, in the data space, we have the data engineer who is covering more the data ingestion, the ETL, so extract, the transform, and load part. And we have also data science, we have machine learning operations. So a lot of personas that want to work with that data in one form or another. We also have business analysts that are more SQL oriented, usually data science, machine learning more Python oriented. And that's why they call Databricks as a unified platform, because they bring all of these personas together in one workspace for collaboration. And this is where you can see here SQL menu point here, menu category. Then you have data engineering, then you have AI and ML. In this session, we are not going to cover all of them, but we'll focus on workspace, for example, catalog. We'll show also some SQL. And of course, here we'll build experiment and train our models. For ETL part, also jobs and pipelines is relevant. You mentioned, Mac, there, coming from the data engineering part, this might be also relevant for the team. You can ingest and transform your data using this part. So why companies are choosing Databricks for analytics platform? I just have one slide for this one. if you think in data and maturity curve, every company is having right now some kind of maturity when it comes to data and AI. Some of them are on the left side here, where they are just starting with it and they are cleaning the data, and then they are moving to reports and ad hoc queries. For example, with Power BI, they have some dashboards, but the scope of it should be to move as soon as faster and with high quality to the right part, which is more AI and machine learning, including automated decision making, which in our case might be also some Gen AI use cases. So moving to this data maturity curve from left to right, this is where Databricks is helping companies with to cover all of these stages in their maturity curve. So if I'm a company, let's say I'm right now more or less on the reports part and ad hoc queries, and I want to move to automated decision making or prescriptive analytics, then this is the steps that I can cover in Databricks as well, and where Databricks can enable me to move in that direction. If I had to put it more in non-technical words, imagine that you are training a team of athletes, right? And when you are training your athletes there, you want them to compete. But those athletes there, they also need a gym. They also need physio. It's not that work on the field, right? If I'm an NBA player, I'm not going only on the field and shoot there. I'm also have to do gym, physio, and I need to have that facility near me. Think about that. Databricks is exactly that facility that supports your athletes to get the best out of them. And those athletes are basically your data or your machine learning model. So this is how Databricks has unified platform model. It's basically your facility to train and get the best out of your data. Now let's move to towards the use case. And for the first part, we are going to do a very nice thing. It's called Auto ML. This feature is not part of the Databricks free edition, but I want to show you because I think it's a good start. And then we move to building our baseline model. So for that, we have to go here to experiments and classification. And we have to choose a cluster here, and I'll explain you what this is. And we have to input here a training set, right? What kind of training set do we want to input? I already have a table here. It's called Churn raw data, and we need to select then the churn target. So what we are trying to predict. These are the columns that are available in that table. These are the features, and what we want to target is churn. So churn means if a customer will leave us or not. And I'm going to give here a name for the experiment. You can also have here some other configuration. You can see all the column names here on the right side. Then we have 21 columns. And next, I'm going to start Auto ML. And once this running, you can see here we configured, and now it's in this step, and then it will go into evaluate. It will take a couple of minutes. Let's take a look at the data first. Let's take a look at the data first. For that, on the left side menu here, I'm going to SQL Editor, and I'm going to show you the table that I have it here. So workspace, churn prediction, and the first one is this churn prediction preparation. This is a notebook that I prepared. You can also find it on the GitHub. And basically it contains that CSV file. I believe you work with notebooks in the past, correct? You know how notebooks work, Python notebooks.
Yeah, I have.
Okay. So this means that in Databricks here, this is what a notebook looks like. And in a notebook, you can switch here, for example, from Python to SQL to Scala to R. This is very convenient if you, for example, have people that in your team, in your data science team, would prefer more R, for example, than Python. In this course, we are going to use Python for our training data. And first here, we are going to define our schema. And then we are going to read the data from this location. Now, what is this location? In Databricks, there's so-called catalog here on the left side. A catalog is a one place for data governance in Databricks, and it looks like this. It's basically, if you work with SQL and with database servers, they're more or less the same. The description is a little bit different. So these are all here catalogs. And if I go down, I can see here the so-called schemas. If I'm going to bronze, then these are my tables here, for example. So we always have here 3-level namespace. First is the catalog, then is the schema, and then is the table. And if I want to visualize the data from here, for example, I can go on sample data and select the compute that is available to me. This will be also available to you in the workspace that you created. And this is how our data looks like. So we have here a lot of customers, a lot of columns about our customers. It's a telecommunication company, for example, that provides services for their customer. We have here tenure, for example, which means that for how long the customer is with us in months. We have different services that the company provides. Like internet service with DSL, fiber optic, so different variations here. You can see that they are not encoded, the values here. These are text values, right? This is something that we have to do it in the feature engineering. And contract month to month, or it's long-term contract, how they want to pay, and important information here, total charges, monthly charges, and the target value which we want to predict, which is churn. So this is how the table looks like, but in normal organization, you usually don't have the information in a table. You might have it in a CSV file, for example. And how I can import that CSV file into Databricks? Well, let's create first a catalog. So we go here to add data, and you can find here create catalog. Let's call it here source system. Yeah. So usually you will have a source system where you extract the data from, or you have a server that someone upload that CSV file to it. With it, we are going to simulate that this will be our source system. And we have created our own catalog, which is called source system. Next, in this source system, we have to upload the CSV file. So how we can do that? We go here to plus button. So we selected the catalog, plus button, and create a volume. A volume, it's just like a container for data. So let's call it data volume. It's a container where you can later upload your file. Great, now we have created our data volume, and from here we can upload our CSV file. We can go here on the right side and click upload to this volume. It's very easy to upload it here. You just drag and drop. Let me choose the Churn CSV file and drop it here and click upload. And now this CSV file is available on Databricks under source system default data volume. Now, if you remember, we started with AutoML. Let's see how this AutoML work in the meantime. So we have here, they already tried some experiments. You can see here that is trying different variation for this model, and is trying to choose which model type alone. So logistic regression he tried here LightGBM, XGBoost, and in the end it will give us a result. Maybe what we can do here, because this will take some time. We can start again. Let me stop this one. Okay, let's start again this one. So we go to experiments, classification, and this time I'm going to give him a timeout. So I select the table again, the prediction target, and the experiment name here, which is SDS. And here, if you expand this advanced configuration, you can find here some evaluation metrics. So what is the most important one? For this one, we're going to choose F1 score. And I'm going to give him a timeout of 5 minutes, which is the minimum. And start AutoML. This time, he will only run for 5 minutes. And whatever he found in that 5 minutes, the best model that he found in that 5 minutes, it will report it as the so-called champion model, right? Okay, so in parallel, this will run for 5 minutes, and we are going back to our data volume. So now we have the CSV file, but we want to prepare it in some kind of table here, right? So that we can prepare the feature engineering and use Python to prepare the model further. So we go to our workspace now, and the first notebook that will have it, and you will also find it in the GitHub, is churn prediction preparation. So what we want now is to read from that CSV file and save it as a table in Databricks. For this, we define the schema again. And here in this, we are going to create a data frame. And we have that option here to read from that volume. For that, we're going to use Spark. My CSV file has header, and this is our delimiter. And the CSV file is having this path. Let me check the path again. So for that, you can go to catalog. Source system, default, and data volume. You can actually copy it from here. And if you go to the notebook, I'm going to paste it in this cell. Now we have to run this from the beginning here. For that, you can choose a cluster, which is this one here, serverless. Serverless means in Databricks that you don't need to take care of infrastructure for that compute. that compute power is available to you, and you use it by selecting it from here. That runs and it's available to you from Databricks, and you don't need to take care about the infrastructure of it. That's why it's called serverless. So we define our schema. Let's try to read the information in the data frame. This is that work. So right now I'm using Python. You can see it also from here. If you want to switch, you can switch to SQL. And let's visualize this time the data from the notebook. Okay, so we visualize the same data, so there should be no differences. We have 7,000 something rows, and in the next part we are going to save this as a table. So we read the CSV file here, and we want to save it as a table, because save it as a table is going to help us having more flexibility when it comes to feature engineering, and to have a better quality of the data. So for that, there's the explanation here. We are going basically to create a new catalog, which is called Churn Lab. And in this Churn Lab, we are going to have 3 schemas: bronze, silver, and gold. These are the so-called medallion architecture from Databricks. So if you go and search for medallion architecture, this is the lakehouse paradigm from Databricks, their main product, which basically have these bronze, silver, gold catalogs, meaning that you ingest the data raw, meaning one-to-one, no transformation. Then you promote it to the silver layer, which means that in that part of the layer, you are going to filter and clean the data. And in the next layer, we are going to prepare the data for machine learning or BI, depending on the use case. So this is just an overview about the medallion architecture. You can find more information about this on this page, but this is what we are replicated on our notebook. So going back to our preparation notebook, we are going to create this bronze, silver, and gold schema, just like in this picture here, like the best practices presented. And you can also see that I easily switch from Python to SQL. Now this is a SQL cell. I just put here percentage SQL, and now the engine, the cluster already knows, okay, this is a SQL code that is coming after, and this is how I'm creating the three schemas. And now we can do the following thing here. I'm going to use a variable called bronze table, and the data frame that we created before from the CSV file, we are going to use it to write as a table in this so-called bronze churn row. And then I'm going to count just for sanity check to see that all the rows are written to the table. Okay, so this worked. If we are going also to try to query and see the data, we can use this query here. We are going to filter here only for DSL and retrieve only the 10. So this worked. It seems that the catalog and the table was created. You can also visualize it again if you go to catalog here on the left side. If you go to the catalog, you'll find here Churn Lab catalog, and under the catalog you'll find the schema. So bronze, silver, and gold. Now we read into gold, churn row, and this is just a one-to-one transformation. Like I said, nothing happened here in between. One-to-one transformation from the CSV file. All right. Any questions until now? before I am going back to the ML flow. Okay, then let's continue. So AutoML now is completed. This feature, so it took 5 minutes. And what is interesting here is that you can check what this is the solution that he tried. So you can see here, he tried first a decision tree, then another decision tree, then 2 times like GBM, and found this F1 score, right? So in this case, this should be the champion model that AutoML created. And you can also explore it if you go inside of it. You can explore it and have the other metrics that explore the metrics that they registered here, the F1 score, and you can also check the artifacts. So you can see that the AutoML have put here a lot of effort to also upload the artifacts. But the most important or interesting part of this AutoML, I tried this this part also with other tools. Usually they have their AutoML for other tools. They're like a black box. So you cannot know what happened behind and why they choose that that model, that specific model, or what kind of transformation or feature engineering they've done in the past. The interesting part with AutoML in Databricks is that it's offering you also the notebook for the best model. And how you can access that. So you can click here, view notebook for best model, and it will open that black box actually. So you can see here, for example, what or why did here the AutoML consider this decision tree with 0.60 F1 score the best model in this 5 minutes of training. I believe if you leave it more, then might find other better solution, but this is what he came out in these 5 minutes. And you can check here, you can see how they load the data. You can try it by yourself, you can run it again on your behalf. The supported columns, the Boolean ones. So he treats also the numerical columns, the categorical columns. So he's doing here one hot encoding for the categorical one with low cardinality. Then it's switching to train, validation, and split. So it is using actually three input data splits, 60, 20, 20, and then it's moving to the training. It's also doing some hyperparameter searching, and then it run here the trials. So this is an interesting part, because the question is this AutoML model that was trained automatically a production-ready one? I wouldn't say that. I wouldn't say that it's a production-ready, but if it gives you a start, it gives you a start in the sense of think about, you might don't have a benchmark in your use case, and you want to find a benchmark ready fast, so that you can compare your actual model with that benchmark to know if you are improving or not. Using AutoML, in this case, it offers you that benchmark if you don't have one. So when building a model, it's important to know with which results am I comparing. How do I know if that model is doing good or not, right? And this AutoML is offering you that benchmark. If you try to beat that AutoML benchmark, then this is a good good starting point. Secondly, you might want to have a data set that you have it or found it in your company, and you want to know if that data set is useful for any machine learning engineering. So instead of investing all of the time to try to find a best model and do the feature engineering and do the model registration, you just start with AutoML and see what the results are there, and see if you can get some insights from that data set which you haven't seen it before or haven't analyzed it. And third reason is, for example, you can also see what kind of reasoning did he found here, what metrics, and how he treated the feature engineering part. So this is one of the reasons that I wanted to show you AutoML. Now let's try. Oops. Now, if we go back to our notebook we are going to start the EDA here, the exploratory data analysis, then move to feature engineering, and then we'll train our own model. Where do you find this kind of experiments? So if you go on the left side here, on experiments, you'll find all the experiments that you have created during the time. And for example, here, the AutoML one was this one, Churn raw SDS. If you go inside, you'll find here all the runs that the model tried. So this is how I went to this page, experiments, and then runs. All right. So let's try to see if we can do a little bit better. Now we are going to our notebook. So I'm going to workspace, to my user, churn prediction, and the next one is exploratory data analysis. Again, we are going to read the data from our bronze table, and we'll take care about some of the quality issues here, data quality issues, and we'll check some distribution for our data. So in this first cell, I'll just going to display the top 5. By the way, any questions to the AutoML part until now? What is it and how it works? Okay, so the cell is running now. Okay, now in the next step, we are going to check the distribution of the target variable, so the churn. And if we run this, we'll find a lot of no's, of course, because churn is not process that happens too often, and this is what we want to detect, that when the churn happens, what are the profile of the customers when churn happens. And in our data set, we have this distribution, which is a little bit imbalanced, right? This is just a plot of the same. And a distribution of the key features. For example, tenure, so how long is the customer with us? we can see that that we have a lot of customers that are new customers, and we also have some customers that are here loyal customers, let's say. Then if we do further with the feature exploration, we are going to explore the contract column. So we have most of the customers are month-to-month customers. They're paying month-to-month, which might be a little bit risky, might be a feature that is contributing to churn in this case. But we're going to see that more in details. Then the same also with payment method. So most of the customers paying electronic check in this data set. Senior citizen and internet service seems that majority of the customers are using fiber optic, of course, and the next part is churn rate by segments. So we can see here the month-to-month churn for yes is pretty high in comparison to 2 years churn, yes, which is only 48, right? So the customers that are paying monthly from month to month are more prolific to churn.
Can you zoom in just a little bit?
Yeah, sure.
Thanks.
Is it better now?
Yes.
Yeah. Okay, great. Yeah. So I was on this part here saying that month to month are more prolific to churn, 1,600. For example, in comparison to 2 years customers that are with us, only 48. Let me also try to close this one here. So now, okay. This is the correlation between tenor and churn, for example, and between monthly charges and churn. So if we put it in a matrix, we can visualize this actually. This is the correlation matrix, and if we plot it, if we plot it here, we can see here total charges and tenor here have high correlation. And in the next step, we are doing some data quality checks. For example, we are checking for null values. It's just a select statement and then casting it and using is null. And if you want to investigate, we can easily do it also with SQL, just where total charges is null. And you will see that we have here 11 rows where total charges are null. So we have to take care of this in the next step when we are going to do the feature engineering. So these 11 columns. So we have, just to summarize the exploratory data analysis, we have class imbalance, churn, contract type, month-to-month might be an indicator there. Tenor is very, very important, so negative correlation with churn, monthly charges, because highly charges might also contribute to a churn. And we also have missing data that we have to take care in the next step. So this is how you can do exploratory data analysis in Databricks inside Notebook. You can switch between cells, between Python and SQL. And next part is to go to feature engineering. All right, in this part, in the feature engineering, we are going again to load our data from the table, the bronze churn row. Okay, we loaded all the records. And next part is what we are going to do with total charges, which are those columns, those rows that have null, right? In this case, I choose to drop that 11. It's not so critical, but if you see the need of keeping them, you might want to choose some other tactics, other statistical methods, for example, to choose the mean or average to fill that null values with meaningful information. In this case, we are going to drop them. So this is the final count. And in the next step for the churn label, we are going to turn yes and no into 1 and 0. So we are going to do this binary labeling. And we are going to take care of multi-value categorical. So this means that we have here columns, for example, no internet service might be treated as no, but we have columns where we have 3 values. For example, we have yes, no, and no internet service. And in this case, we are going to treat no internet service as no. And then we are, when we have only yes or no, then we are also embed that and encode that into 0 and 1. And these are the columns that have those 3 values. And there's also one column which is called multiple lines that we are going to do the same for them. Now, if you visualize those changes, then we should see here, let's scroll a little bit down. The churn label, now it's 0 and 1. Senior citizen. And also this multi-lines is having now only yes or no. In the next step, we are going also to treat them as 0 and 1. So encoding categorical features, yes or no, 1 means yes, 0 means no, and one hot encoding for the multiple category variables. We are going to do this in the next step. We are going to define a helper. And for example, we are treating the gender. We are creating a new column called is female, which will have 0 and 1. This is how we treat gender, male and female. And this means that we added a new column here, which is female. The same also for other binary columns. We have here streaming. We have streaming movies, paperless, billing, 0, 1. We have treated them as binary columns, and we transform them into 0 and 1. Now for the multi-category features, for example, contract, we have three values here, month-to-month, 1 year, and 2 year. And the same also for internet services, where again, we have 3 values. And 4 categories for payment method. We are going, because they are low, they have low cardinality, we are going to treat them and create separately these columns. And we are going to drop the columns that we don't need anymore because we created new columns. And checking what was done until now. So this looks much better for a machine learning table, which contains 0 and 1s. but we still have here, for example, tenure. So how we can do that? What we can do with this? We can create buckets, for example. We can create buckets, meaning that if the customer is with us for less than 1 year, this is we treat it as a new customer. 1, 2 years, it's establishing loyalty. 2, 4 years, stable customer, and more than 4 years, it's a loyal, long-term loyal customers. And this is what we are going to do in the next step, where we are creating the buckets here. And then for every bucket, we do again the one hot encoding. This is the most simplest way here. You can also do different things here, and treat it a little bit differently. But in the end, it's about transforming that information into something that is useful for machine learning. So displaying that information, now you see you will have also 0, 1, 1, 2 to 4 and 4 plus, which are the loyal one. So this would be a loyal. All right. Business insights. You can also create new columns. For example, combining 2 or 3 columns from the existing features. Combine 1 or 2 columns and create an extra feature. In this case, it's might be useful to know how many services did that customer bought from us. And this is what we are going to do next here. So in this number of service, we will create a new column. Let me check. Can you still see my screen? No.
Yeah, you can still see it.
Okay, 1 second. Because I think I lost a little bit one monitor. Sorry for that. Let's see now. Yeah. Oops. Let me try to input the HDMI cable once again. All right, so oops. One second. So on your desktop now, it's appearing the Databricks, correct? The notebook.
No, I don't see it yet.
No, okay.
Anyone else see it?
No.
Okay, then we
No,
do this.
either.
How about now?
No, still no.
No.
Okay, let me try to share it again. Entire screen and share.
Yep, there it is.
Yeah, okay. Great. So we were here from the Zoom still works, right? The Zoom, it's okay now.
Yes.
Okay, great. So sorry for that. I think it was something with the sharing. We were here at this step where we wanted to define a new column. We wanted to define a new column, call number services, just to know which customer, how many services has bought in one simple column. And this is what we have done here in this cell. So going down, we can see here, for example, we have customers with 6 products, with 4 products, also with 1 product. And this is information that might be useful in the future. So this is how you can basically combine one more than one feature to create new meaningful information. And then at the end of exploratory data analysis, we want to save these features, to save this format that we created a feature engineering table. We are going to save it as a table to this path gold churn features. All right, so now if we are going to our catalog again, so going to left side catalog, churn and gold, we'll find our table here, churn features. And if we sample the data, then it should now show us the new version of our table. So this is exactly what we have created in the exploratory data analysis notebook. Now, the next step would be to train our model. So let's go to the workspace again, and we are going to choose the third notebook, which is model training and evaluation. For that, we are going to use an XGBoost model and using Unity catalog and ML flow for that, for register a model. And in the end, we are going to do some inference to check the values. So first, I'm going to install on this serverless cluster here. I'm going to install XGBoost and SHAP for checking what are the most important features. This is how you can install new libraries in Databricks notebook. Okay, now we are going to import some of those libraries. And we are going to give here an experiment name. Let's choose another name because this is already, I have it. Churn prediction XG SDS. So this will be our experiment name. And we are going to load our feature table, the one that we have created earlier. We can see the shape of it. So we have now discount and also 35 columns because we expanded the shape. And we are going to use to define our features and target in the next step. First, we are going also to drop thinner bucket, thinner bucket, because we already have it as encoding columns, churn label, which is our our target, and customer ID, which is not relevant for the training. We are going to use train and test, so no validation for this lab. As you saw, AutoML choose also validation, so a validation set. So the split with AutoML was 60-20-20. In our case, we are going to use train test, and it will be 80-20. And we also want to make sure that the stratification of Y is done correctly, so that we have more or less the same number of churn rate in train and set here. This is what we are taking care in this part. So we want to have more or less the same number of churn in train and test. Then we are going to train a baseline XGBoost model using ML flow. And this is the interesting part here. So basically, with this code, with ML flow start run, this will be our run name, baseline training, and we are going to give these parameters here. Now, these parameters, you can also tweak it later and try different options. I'm going to choose this one for our model. And then I'm going to look, for example, the area under the curve and also the F1 score. So let's run. Now you can see here, one run is logged to an experiment in ML flow. You can also click on this blue button here to check the experiment from here. You saw that they uploaded the artifacts here, and we print here the run ID, the area under the curve, and this is our F1 score. And we are going to do some optimization here to maximize it. So why do we need that? We are going to check in which part of the training model was the F score the optimal, or had the optimal threshold. This is what we are going to do in this step here. For example, some of the models, this threshold is in the middle, so 50-50, but in this case, it seems like it was on this part. And we are going to use this SHAP to explain which features matters most in our model. You can see here on the top, contract month to month, internet fiber. So these are the 4 most important ones. You could also guess that month to month is a very important one, right? And then the others are more or less the same from the priority, but these top three were the most important ones, seems like. And for that threshold, you can also plot it like this. So why choose that threshold here, 0.447? So why not in the middle? Because at this point, the F1 score was the highest, right? Okay, so we train our model. Next step is to register the model to Unity catalog. So you can also save it there and have as artifact together with your table. But first, let's take a look a little bit at the experiments. So on the left side, we click experiments. And you can see here our name, XGSDS. If we go inside of that experiment, you can see that we have trained this our run. You can also check the data set from here. It's a XGBoost model. And inside of it, you can also cover or That's the metrics that the model logged, and what kind of artifacts were published here. You can see here also the requirements txt if you want to reproduce that, and the picture with the features importance. If you want to log more, of course, this is also possible. And in this overview, you also get a link to the notebook that trained that model. And in the model metrics, you see as a chart the metrics that we were published. Recall F1 optimized, so a little bit of optimization. And let's say now we are going to register this model to Unity catalog. So we are going to give it as alias name. Let's say this would be our champion model. Of course, you want to hyperparameter to do some hyperparameter tuning, maybe with optional in that place. But this is only for lab purpose. We are going to use this to register this model under this name in this catalog and schema. So Churn lab in gold. And alias name is champion. So this is what the code is doing. And you can see here model register Unity catalog as under this name, alias is champion. And if you want to load that model, you can use this here. So how does it look like in Unity catalog? If we go here, switch back to catalogs, we go to gold, and you can find here models. Now you can see you have two models. One I did before, one is from now. And if you want to check, you can also check here the versions. So the champion model is actually at version 9. And this is also the latest one. So with this model tracking, you can check how the model improves and what is changing between the versions. It's tracked here everything. You can go inside the version and see what changed. You can also check some lineage, the artifacts that were published. You can compare. You have all the transparency that you need to understand if the model drifts at one point in time, what was the reason for that. So going back to our notebook, now we want to run some inference using that model. So what are we going to do? We are going to load the model here. And we are going to do some final predictions. Using that model. And this is a print of the first 5 records. Basically, with our model, we for this customer ID, we had these predictions, but we want to compare it with the actual. So this is what we are going to do in the next step. We're going to have an evaluation. And you can see here that, for example, on this one, the model did good. This one also, but on the first two, we basically predicted that the customer will churn, but it didn't churn in the actual data set, which from use case perspective, it's not so bad because it's a little bit conservative, right? We want to understand what was happening when where are the use cases where we are not predicting correctly, and in this time here, basically someone needs to take actions. So needs to check that customer, for example, and offer some insensitive so that that customer doesn't churn. So it's a little bit of visibility. Hey, here this one might churn. In the actual data set didn't churn. Other way around would be more drastic, I would say. Now we have some confusion metrics also in the notebook. And you can see here also the threshold for a churn prediction model with no optimization. The results here are moderate, I would say. A lot of potential for improving, of course. But if we want to take this as information, then we might want to check this 91 cases that didn't work well, for example, right? This is the interpretation. So we have these one are important customers who didn't churn, but we predicted as who did churn, but we predicted as non-churners. I think these are the most important ones that the company has to analyze it, for example, right? We also have here, so most of them are customers who did not churn, and we are correctly predicted as non-churner, so the most of it. Customer who did not churn but were predicted to churn. These are the false alarms. And then the true positives, customer who did churn and were correctly predicted as churners. A little bit of business interpretation here. So as I said, it's important to for the team there to get in touch with that 91 and see what they can do in that place. So in this session we cover a lot. We started with AutoML. We train a model with AutoML and saw how we can actually check what happened in that AutoML. It's not a black box actually in Databricks. You can go and check the notebook that AutoML run behind for the best model. And we got an F1 score there, which was 0.59 or something. And then we train our own model, simple one with no optimization or no optional, for example, and we get another F1 score. This is what we cover in this session. Any question, please?
Yeah, I have two questions. One is that so this was very good, although I didn't follow everything. So I want to
Nice.
run this in my Databricks environment.
Mm-hmm.
So I see the GitHub. I also want to try, and I understand that AutoML does not work in our free environment, but
Correct. Yes.
I want to try AutoML in my work environment.
Mm-hmm.
Is there a place I can get that notebook? Is that in the
Yeah, sure. So let me show you actually how you can download it. So in this GitHub repository, you have two major files here, the CSV and this DBC file. So this one you can actually download it. So you can go here and download the DBC file. You have it here. And if you go to Workspace, so this part here in the menu, and under your username, you have these three buttons here and click import. Now here you can drag and drop or select that DBC file. I'm going to select it from downloads folder and click import. And now this will create a folder here with all the 4 notebooks that we tested in this lab.
Okay.
And for the CSV file, I show you how you can create a catalog here and upload it to the volume.
Yeah. Yeah.
the volume. And from there, you just need to go the notebooks one by one, starting with the preparation one.
Okay.
If
So
you have questions after that, if something doesn't work, just ping me a message, and we can jump in and help you to set up.
Okay, I'll do that. Thank you.
Welcome. Any other questions or feedback? It was too technical, or should it was enough of hands-on from your opinion? This will help me to structure, for example, the next labs more targeted, and to help you more with that.
I'll have to see how I'm able to do this myself, and then I can give you some feedback.
Sure. Feel free to ping me if you encounter any problem. I can help you also to set the Databricks free edition, or to create the Unity catalog. Just post a message there, and we can jump in. All right, then let's close this session. We are a little bit late, but I think it was useful to cover everything. I didn't want to stop, and I wanted to show you what I have prepared for this one. And next session, maybe we can take a look at a little bit more on the lakehouse part of the Databricks. Maybe also do some hyper optimization, so hyperparameter optimization of Optuna. These are all valuable information that we can do in next section. Thank you very much for attending it. Until then, enjoy Databricks, and looking forward to see you in next lab session. Thank you.
All right, thanks.
Bye-bye.